Hello, we are team number 69, KB Designs, presenting the final model of our tricycle design. Our tricycle is approximately 0.8 meters long, 0.75 meters tall, and 0.45 meters wide. In designing our tricycle, we kept safety and comfort as our top priorities and searched for features which held true to these ideals in our market research. The key points which we wanted to incorporate into our design were a high-backed seat complete with a grip on the back and wider pedals. We also wanted to ensure that our tricycle would be sturdier than others on the market and chose to construct a metal frame instead of a plastic one.
Our tricycle consists of 12 part files in total. Our frame, which includes an angled socket for the handlebar, as well as a perch for the seat to be placed upon. Our frame also includes a channel for our back axle to be inserted into, which will hold our back wheels with a tolerance of 2 millimeters in order to allow for unobstructed rotation. Our small tires at the back of our triangle measure approximately 15 centimeters in diameter, with a thickness of 4 centimeters and a triangular treading pattern to better allow for grip.
Our large tire is approximately 30 centimeters, twice the diameter of our small tire, with the same triangular treading pattern and 4 centimeter thickness. Our large tire connects through our frame with our axle with a tolerance of 1 millimeter in order to allow our axle to catch the wheel enough to cause them to rotate simultaneously.
The seat has a height and a width of approximately 12 inches, or 304.8 millimeters, providing enough space and backing to prevent possible dangers. Along with the backing, we attach an ellipse-shaped opening, slightly below the highest point on the seat. This hole, 88 millimeters in width and 46 millimeters in height, provides enough space for another individual to hold on to should the child seek assistance. For a more comfortable experience while using the KB Tricycle, we had reclined the seat a tad to prevent strain on the child's back.
In our assembly, we began by placing the frame on a plane and properly orienting it. We then placed the handlebar and the grips, which have a 1 millimeter tolerance with each other, to allow the grips to be removed and interchanged. We connected the handlebar coincidentally to the grips, and then did the same with the handlebar and the frame, which has a 2 millimeter tolerance to allow for rotation. We then assembled our two back wheels and our front wheel with respect to their corresponding tires. We then connected our pedals to our front axle and our back axle to the frame. We then placed our front tire underneath the front of the frame, locking them together by inserting the axle with pedals attached through the center of the wheel. We then placed our back tires on the back axle in the same manner. To finish our assembly, we placed the seat atop its designated area on the frame. In order to lock these two pieces together, we placed a screw with 1 millimeter of tolerance through the base of the seat and the perch on the frame.
Playing above the simulation of the tricycle functioning. Before we can get started, we first fix the location of the frame. If this is not done, then the simulation would appear incorrect, and you might witness the rotation of the frame entirely, rather than the wheels and the pedals. We attach a service motor to the front and back axles in order to make the large and smaller wheels rotate respectively, as you can see above.